Hey, in this short video, I'm just going to show you how we can use a custom plugin for Wireshark and decode SAP traffic to help us better understand what's going on with SAP and make sure that we can properly configure Zscaler Private Access to do this. So I've previously shared the SAP configuration guide and some links to the Wireshark build for both OS X and Windows that includes the custom SAP configuration plugin. So you don't need to go off and build that. It's version 2.6, a slightly older version of Wireshark, but it's perfectly functional. Configuration guide kind of walks through what is going on with SAP and how to diagnose this traffic, and in the end it kind of links to the plugin and how to go ahead and get the builds that I've provided to you. So do take a look at that. But here's what we're going to do. I've got an SAP packet capture here. It's important to talk to your customers, get the SAP traffic understood, and have a look through the packet capture. So you'll see some SAP messaging, you'll get some SAP diagnostics. A lot of this, there's some relative information in here that's kind of useful to diagnose a lot of SAP, but really for Zscaler Private Access, we're interested in how the communications work, what is being signaled back, and all of that. So a couple of things that are interesting. If you look at this packet capture, there's some interesting things that go on with the port translation. Again, 1.5.2 of ZApp will address the way we mangle the source IP, destination IP, source port, destination port. You see some interesting things here. 192.168.0.99 is actually the client. 10.32.50.8 is actually the server. We've mangled the port on some of this. But we're really interested in what the messaging traffic is, and specifically the message type 5. Message type 5 is a response from the server. So if we filter on sapms.opcode equals 5, this is our message list, and this details the actual IP addresses that are seen from the server. So the first entry here, 10.56.13.18, and you'll see the host address is the same. This is the connector IP address. So this is the SAP server saying, hey, I see that you're coming from this IP address. And based on that IP address, I can tell you that there are a number of different SAP servers available. 10.32, 50.185, 127.0.0.1. Let's ignore those two, but these ones are the ones that are interesting. So this is the actual SAP server name, the logical server name. This is the DNS name. Now remember, this is a short name, so we need DNS domain suffixes to be applied to this to make a fully qualified distinguished name for DNS lookup. Actual database service name that's running on there. The IP address of it, and then this is the port that the service is running on. So what we'd expect to see is a connection, if you're on the network, to 10.32.50.37 on port 3202. That's your SAP data connection. On ZPA, if SAP is configured appropriately, I'm not going to say correctly, but appropriately, it will signal the client to create a fully qualified distinguished name, QEERAP01.domain.com, and when the client makes that request for what is the DNS name of it, rather than it resolving to this IP address, which it would on the network, because it's a fully qualified distinguished name and it sits within the namespace of the customer, then it should resolve to a 164.10/24 IP address, which is the ZPA domain, and it should just work. However, customers tend not to want to tinker too much with their SAP configuration. If it's working on the network, it should work via our remote access tool, and therefore we need to be aware of this IP address, and it's this specific IP address that we should configure as an application segment on ZPA. Now, the other interesting thing is we scroll through here, there's a couple of other values, and it appears as if SAP wants to be able to connect to every single one of the hosts that is listed in this message data, and if it finds one that it cannot talk to, then it will fail. So you need to get a packet capture. Invariably, you can do this on the network and say, hey, start up SAP, let's see the message data, let's filter this down, and once we know what all of these IP addresses are, we can configure those as a single application segment, listing each of these IP addresses and the relative ports, 3200 in this case, as an SAP application segment. And that avoids you needing to do the wildcard 10.0.0.0/8 or even 10.32.50/8. We don't really want big subnets advertised via ZPA. What we want is to be, managing it by an FQDN and only configuring by IP address if absolutely necessary. Now, in this specific one that we're looking at here, we'll see the similar kind of database listed multiple times, and invariably this is because of the way the SAP load balancer works. It goes DPO1. We'll scroll down a bit further. We might see DPO1 again. It's a different server, different IP address, and the way that works is you've got the SAP database running on multiple instances, multiple IP addresses, and when the client logs in, they are then directed to one of those instances. So it's kind of like an out-of-path load balancer. Hey, which server should I connect to? Should I connect to A, B, C, or D? And it'll go, D is unloaded at the moment, connect to D. So it's important that the client can connect to all of these by IP address if that's the appropriate connectivity model. And that's interesting in its own self, because when the initial connection to SAP occurred, we know that the source IP address here, 10.32.8.170, this is the IP address that the SAP load balancer saw as the client request. So this is the IP address of the connector. If, when the user then makes their subsequent connection to this server here on this IP address on this port, if they're seen coming from a different IP address, i.e. we made a different load balancing decision within Zscaler, so they egress through a different connector, then the session state will change, and that can cause problems with SAP. So the thing you should do on that is look in your ZPA diagnostics page, understand the source IP address, which connector within the connector group the traffic went through, and if that has changed, then we might need to look at how do we load balance that traffic differently in Zscaler Private Access. So hopefully that gives you an understanding of kind of what's going in with SAP, how the ZPA load balancing works, how the SAP load balancing works, and why we were interested in taking a packet capture, understanding the traffic flow, and diagnosing the problem. Hope that helps.